Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll find the derivative of these trigonometry functions. So as per the problem, determine dy over dx for each of the following. And we are given these three functions. So let's start with the first function, y equals tan 3x. So the dy over dx, or the derivative for this function, can be found using the chain rule, because this trig term tan 3x has an outer function tan and the inner function is 3x. So we'll start with the derivative of the outer function, and the derivative of tan is secant squared. So the first term is times the derivative of the inner function, and the inner function is 3x, and the derivative of 3x is 3 times 1. So 3 is the coefficient of the term, so it stays as it is, and the derivative of x is 1. Now we can simplify this expression. So 3 times 1 is 3, and we can multiply 3 by the secant square term. So we get, so this should be the final answer for the first function. Now we can analyze the second function. So we have to find dy over dx. Now this function has two terms. So in the first term, 2 is the coefficient of the term, so it will stay as it is. And the derivative of tan x is secant square x. Now we can find the derivative of the second term. Now the second term is made up of the tan function, and there's an inner function 2x, which is a polynomial function. So we have to use the chain rule. So as per the chain rule, we start the derivative of the outer function, and the derivative of tan is secant square times the derivative of the inner function, and the derivative of 2x is 2 times 1. Now we can simplify this expression. So the first term stays as it is, and in the second part, so we can multiply 2 by 1, 2 times 1 is 2, and then we can multiply 2 by the secant square term. So this should be the final answer for the derivative of the second function. Now we can analyze this third function. Now the third function has a square on tan. So the first step is to rewrite this function so that it becomes easy to find the derivative. So now we can see that this term has the outer function, which is the exponential function with the exponent 2, and the inner function is this tan term tan x cube. So we'll have to use chain rule to find the derivative. So we'll start with, so for the derivative of the outer function, which is the power 2, we'll have to use power rule. So we'll move the exponent 2 to the front, and we'll subtract 1 from 2 times the derivative of inner function. Now the inner function is a composite function, so we'll have to find the derivative of it using chain rule. So we'll do that in the next step, But in this step, we'll just show that we have to find the derivative of the inner function, which is tan x cubed. Now in the next step, so in the exponent, 2 minus 1 is 1, and we don't write 1 as an exponent. And now we can find the derivative of tan x cubed. So as I mentioned earlier, there is a composite function. So the outer function is the tan function. The inner function is x cubed, a polynomial function. So we'll have to use chain rule again. So we start with the derivative of the outer function, which is tan. So the derivative of tan is secant squared, times the derivative of the inner function, which is x cubed, and we have to use power rule. So the derivative of x cubed is 3x squared. So we move the exponent 3 to the front of the term and we subtract 1 from 3. Now we can simplify this expression. So we can multiply 2 by 3x squared, so we get 6x squared. So this should be the final answer for the derivative of this function. So I'll just put x cubed in parentheses as it's given in the function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.